All right, good afternoon, everybody. My name is Brunno Moretti. I am the VP of Product at Cepton. Cepton makes LiDAR devices and software for autonomous and ADAS vehicles, and I'll be your lead panelist. Is it? Okay. And then I'll be your lead panelist today, so super excited about this talk. We have a lot of people in the industry here. A little background of myself. I've been in and around the auto industry for 15 years. I spent about a decade at General Motors, a couple of years at ZF, one of the major Tier 1s, and now at Cepton. So now I'll give the opportunity here for my panelists to introduce themselves and talk a little bit about them, what kind of work they do.
Great, thanks. Omar Iftikhar, product manager at Ford, focused on self-driving vehicles and what's going to take to integrate it to our infrastructures and get people in those vehicles and start seeing a shift towards autonomy.
Emmanuel, Gillis-Harry, AI ML scientist at General Motors, focused on just bringing AI ML solutions to all parts of GM.
Qian, managing counsel at Cruise. I lead the product risk and liability team, and at Cruise, we're building driverless vehicles for ride-hail and delivery.
And I'm Renata from Sama. So we're a data annotation platform. We work with all of these different type of customers to do the data labeling for them, curation as well, and validation.
All right, very diverse panel here. Let's get it in with the first question here. So the public is pretty focused on autonomous driving, right? And one particular use case, exciting use case for AI is automotive. So what is the current state of AI adoption in the automotive industry, and where are we seeing adoption? First, we'll kick it off with Emmanuel on that one.
Yeah, so definitely the automotive industry is very open. Like, we welcome AI solutions with open arms. Like I said, in all departments. GM specifically, we focus on customer experience, improvement of product in terms of vehicle and also software, and also like the whole building from ground up, improving that whole situation.
Yeah, so I think too there's a lot of work doing in especially in the sensor side and in compute side. There's a lot of machine learning in order to get perception systems to really be able to classify those objects and be very confident, right? And I think data annotation is one of the biggest parts of that. We see that as one of like a Cruise with the driverless vehicles, and then you have the other OEMs working on level 2 and level 3. And maybe for some of you that don't know, level 2 is, the driver is still in the loop and engaged. Level 3, this is something where you can disengage your mind, but you have to give it back I think the vehicle has to give it back to you about 10 seconds. And then level 4 and level 5 is, completely driverless, no driver in the loop. So I think the AI, very specifically in that case, is very useful. A lot of that work is going on to make those things happen. And, but there are also other areas, like user experience and, different areas of the vehicle that's also using AI. There's a lot of the back-end data collection and monetization too that can use that. So we see a lot of use cases with AI, but mostly, in my view, I think it's really for the ADAS and the autonomous vehicles.
Maybe I could add in-cabin monitoring for security purposes, so understanding what's going on inside of the car. That's things that we see too. And if we think about like different industries that are like crossing, or like the way that you can, the manufacturing piece, like let's say you're assembling things, I'm pretty sure there's a lot in there like automating processes and quality checks as well.
Yeah, that's an interesting one, right? Because as you get to, driverless vehicles, robotaxis like Cruise, for example, somebody leaves a purse, somebody leaves whatever, forgets to close the door, right? So instead of having somebody monitoring that's very inefficient, right? So using AI into those use cases is super interesting, right? So that's, I think, that whole business model created this other need to have AI into the vehicle. So it's super exciting.
Yeah, that's absolutely right. So we know in the driverless, especially driverless ride-hail space, AI is kind of core at powering the vehicle, but also on the rider experience side, right? Like what you mentioned on in-cabin monitoring, and also even the rider experience, there's definitely a lot of opportunity in blue sky there on how we could leverage AI for like a just amazing rider experience.
Yeah, and I think even on the personal vehicle, right, there is a use case where in one of my past jobs, we were working on child left behind, right? So you close your vehicle and you're okay parent and you forget your kid, the vehicle will remind you, it'll sense that there is using either radars or cameras or lidars. It will sense that there is movement, there is heartbeat, and it will actually send a message from the vehicle to your phone to give you that reminder, even with pets as well. So it's very exciting. Anything else? If not, we'll move to the next question here. All right, different levels of autonomous vehicles each carry with it different goals and challenges. Let's elaborate a little bit more on that. And Omar, let's kick it off.
Yeah, sure. So I think you touched a little bit on what level 2 and 3 are, right? But just putting things in perspective, right? So the two ends of the spectrum you start off at level 0, which is no autonomy at all. So you can think back 20, 30 years ago when we had cars and there was no cruise control or nothing. So it's completely focused on the driver, right? And the other end of the spectrum would be a level 5, which is completely autonomous. And in that case, you're thinking no steering wheels and no pedals, right? And so if you were to kind of envision and look at what this vehicle would look like, it would be kind of like you open your car doors and there's just a few seats, right? And maybe the seats are facing each other. And so you kind of get in this car and it takes you around, no steering wheel, no pedals again. And so that's what the future looks like for autonomous vehicles. And that's the end goal where I think we're all trying to get to. Where we are today as an industry and what most OEMs are doing falls somewhere between level 2 and level 3. So the cars that you see out there today is somewhere between that level, right? And so OEMs are pushing really hard to get to level 4 within the next couple of years or so. And there's been great progress in that regard. There's some promising results from different OEMs that are trying to get to level 4. And level 4 is really when you'll start to see a very minimum effort from the driver involvement. So you're having a lot of these self-driving missions. And so the idea is for drivers not to be able to be engaged as much as we'd like for them to be. So speaking of where we are today, some of the challenges that we have getting to level 4 or even level 5 in the future, I think it really comes down to two things, right? And number one is it's such a software-driven and software-dependent industry that we're in within autonomous vehicles, right? And so obviously you need the hardware and the software both for it to kind of become possible. But if you think about it, you can essentially put the same hardware in a Ford, a GM, a Chrysler, a Tesla, right? But what's going to differentiate the way that these cars perform is how well you write your software, how well your algorithms perform, right? And so you have one vehicle that might be doing really well, right? And no bugs, and this car is driving as well as you'd want it to be. And then you have another one that's maybe not as effective, efficient. So really what it comes down to is software, right? How well can you design these algorithms? So there's a lot of emphasis on hiring talent, bringing in some of these software experts, and OEMs are actually starting to look towards other companies that are outside of automotive. So we're looking at tech companies to hire talent from there, leverage their software skill set and bring it to automotive and help us kind of build a better self-driving system. The other thing which I think is very important with self-driving vehicles is the environment that they're in and the infrastructure that we're building to support these cars, right? So you can essentially build a great autonomous vehicle that performs really well on the freeway, but as soon as you take that same vehicle and put it in a heavily populated area, it might not perform as well as you like. And the reason is because all of a sudden you're giving this vehicle all these data points, right? And there's so many people, and it has to process so much more than being in a freeway environment. So we really have to think about what's the environment of these vehicles, and that's kind of tied to this whole aspect of building smart cities, which a lot of countries are looking into, right? How can we better build our infrastructure to support some of these autonomous vehicles?
Right, absolutely. And to add on the infrastructure point, right, that's a big challenge because it requires a lot of public stakeholder buy-in. And we all know that infrastructure investments are very immensely costly, right? And they take long times, like years, sometimes decades to implement. So that in itself is a large, like, operational and policy level challenge.
I was going to add in a third point to that is the general population adoption. in the sense that, how many of the customers really want their cars to be completely autonomous? If you want to go off-road, you want to be able to have that option. So having the general public to make acceptance and adoption of it is something that should also be taken into consideration. It's a lot of feedback, test cases, and so on and so forth.
Was that me? No? I think one video that I watched yesterday, since I work in the industry, I always get sent this like Instagram reels or whatever of Tesla. And there was one, I think it's all about like edge cases, right? Like there's always like this edge case that arises and it gets to social media and everyone gets to see it. And I think the one that was very funny for me to see yesterday was a carriage. Carriage, is that how you say carriage?
Carriage?
Carriage, yes.
Yeah.
Like this thing with like a horses in front.
Carriage.
Carriage. Yes, carriage. Sorry, that's my Latin American accent. And the funny thing is that he was trying to detect that object, right? And he just swapped detection to detection. And from a truck, it became a person. From a person, like a bicycle. And of course, the car will not behave the same way if there is a person right next to them or if there is a car. So there's always that challenge of like getting to that last mile of edge cases.
Yeah, and that actually on the reel, I got also one reel where you see a Tesla blow through a kid mannequin, right? And that's one of the things that, if you actually look at the report that NHTSA put out not long ago, maybe a month and a half, it shows that current ADAS systems in the road today are, very, very poorly performing when it comes to those cases, right? So pedestrian fatalities, they actually have been rising hockey stick wise really, really rapidly during nighttime, right? Where you got cameras and you got radars that are, not really seeing it very well. Radar has sometimes problems with identifying smaller objects, right? With the radar cross section, and cameras at night, of course, kind of like our eyes, it's a passive sensor, right? So, and that's where LiDAR actually helps fill in that gap, right? And, for us at Cepton, we don't think LiDAR is going to substitute any of those sensors. We're complementary. We're, again, out of those edge cases, really that's where LiDAR comes in and really helps fill those gaps. And that's a super interesting part of it because, what we do really, what everybody's doing here is helping save lives at the end of the day, right? Those vehicles are going to be safer on the roads, safer to be driven around, and safer for people that are walking on the roads, right? So really all the work that the team here is doing is to really get to that next level and continue to reduce the number of fatalities, so.
And maybe I could add just an extra piece to that because as you say, like how important it is to have like the right sensors or like the right type of data to know what's going on in the surrounding. There's also like when you are getting that data to the models, like there's an opportunity of, at Sama, for example, we do data labeling, right? But like we have a workforce that is doing that data labeling. So leveraging that workforce into understanding what is on your data is extremely important. So of course, you can notice like there's like certain edge cases or things that they will just rise. It's like, hey, what should I do with this? What should I do with that? Like there's no instructions for this case. Like what do I do with that? So leveraging those pieces of information as part of your model creation will be also key to ensure that those edge cases, of course, maybe the carriers were not going to be in the data, or maybe there was one and that edge case was not recent, like they didn't rise it, so they didn't know what to do with it. So I guess that's a very important like element on building models.
Very good. All right, on the level 4, level 5 vein, what are the challenges that exist in the path of widespread adoption of those vehicles? What are the necessary steps to overcome them? Lily, we'll start with you.
Yeah, so Omar earlier touched on kind of the nuances between level 5 and level 4, right? So level 5, if in its purest sense means that it could operate basically in any operational design domain, right? That's off-road, no matter the weather, no matter the geography. There are no exceptions to where the car can operate fully autonomously. So on that, there is still a ways to go in technological development, right? Today, we still have very real restrictions on what our sensors are capable of, and also when it comes to motion planning and control, what the vehicles themselves can do on certain types of roads. So there's a lot of technological advancement there. We also talked about the infrastructure that would be needed for truly level 5 kind of widespread adoption. And then stepping over to level 4, which is where Cruise is at today, we are driverless in San Francisco in a defined operational domain. There's a couple of major challenges. They kind of are around scaling, they're around public opinion, which Eric touched on earlier, and then also around the regulatory framework, right? So on scaling, making a small handful of AVs, autonomous vehicles, that operate the way they're supposed to, is a very different task than making, say, thousands of AVs operate smoothly in a domain. So there are many nuances to that challenge. Then on the public opinion piece, I think it's worth mentioning that, like, in a sense, we're all in this together. There's this like concept that there are a lot of things that are outside of our control. When one of your competitors or some other player in the industry makes maybe reckless or just unsound decisions that results in a road fatality, that sets back the whole industry, right? Because that erodes public trust, and we're very conscious of that. And like we, especially in the level 4 space, we're very aware that even if it's not a Cruise incident, any of the other kind of fellow competitors in the space, if they were to have an incident of a certain severity, that could really set back adoption by years, maybe a decade. And lastly, around the regulatory framework, that's, I could spend the whole time talking about that. So, but largely it's around the nascency, right? We don't really have mature or strong frameworks built out around that to like basically help foster or nurture widespread adoption.
Yeah, so I think the other thing is system costs, right? I think when you do have to do this kind of ODD, right, which is the operation design domain, you really have to have sensors everywhere, right? So I think that's one of the challenges, is bringing down the cost of sensors and compute in order to really make that a reality. And I think one of the paths is the ADAS, the level 2s and level 3s. Once those vehicles, because they're now just really kicking off like really high gear, once those get into mass markets and mass volumes, the economies of scales for those vehicles will then transport the lower cost than the level 4 vehicles, which will help enable them even faster, right? So I think one of the challenges we see today is cost, but with the adoption of those sensors more and more in the commercial, or not commercial, but the owner vehicles owned by people, it's really where I think it's going to help enable that adoption even faster. Okay, moving on here. All right. Cars these days seem to be more like computers more than ever. What developments in AI are enabling the connected and autonomous vehicles, and how does it translate to a better user experience for the passengers? Emmanuel, we'll start with this one with you.
Yeah, definitely have it's a lot of points to touch on this. I won't take too much time. But for starters, safety. Safety is always going to be like the priority. You bring in AI solutions into vehicles. The biggest topic is autonomous cars, right? The idea is like, okay, safety comes first. So in that, from a computer system, it's like you don't have to really worry about too much. Then you start moving more into personalization. Like think of how you went from the old Nokia phones or the flip Razor phones from back in the days. So now you have your iPhone, which now became like a mobile computer that had more accessories in terms of your Apple Watch, or if you're using Samsung, it could be a whole different case. But it creates a whole different ecosystem. So now think of a car that went from, we'll say the prehistoric version to now. It's so much technology is put in it that you could access information at your fingertips with a mobile application. So let's say you forgot to lock your car and you're a distance away, you can lock it from your phone. Or, if it builds up a pattern, it could be like, okay, Emmanuel forgot to lock his car again at this point. Let's lock it for him. Or you need to cool your car like at a certain time, like you're getting out of work. I live in Houston. So imagine you get out of work at 4 or 5 o'clock and the heat's, been heating up the car, and the AI in the system learns, okay, Emmanuel gets out of work around like 5 o'clock. So maybe at 4:50, let's turn on the car for him, and so on and so forth. And just even thinking about the health of the vehicle. So preventive maintenance. So like, I'm not gonna lie, I forget to, do my oil change sometimes. I forget to refill the windshield wipers and so on and so forth. So imagine like you have like forecasting data integrated in there where it's like, okay, it's supposed to be a heavy raining day in the next 5-6 days. Where's Manny's vehicle's windshield wiper fluid on? So a lot of those personalizations, safety, awareness of your property, and just overall peace of mind. That's what I'll say that leans on to.
And on the note of connected cars, because this is related, the idea of swarm technology. So, fleet operators of autonomous fleets are thinking about this and how it can really benefit the passenger experience, right? So, how many of you would have a better experience if there was less traffic in your life, right? So just very obvious solves that a swarm technology, this idea of vehicles being connected to a shared network would be able to benefit from.
Yeah, I mean, I think there's just, if you think about all the advantages of being in a connected environment as with talking about vehicles, I mean, if you take it one step further and talk about the concept of vehicles communicating with each other and connected to each other, right? You could essentially try to limit or eliminate so many crashes, right? If vehicles start talking to each other, that's one big one. So the importance of having a connected infrastructure for vehicles where they're all connected to the cloud, potentially talking to each other, and then sending data back to the cloud that really is going to help the OEMs. It's going to help dealerships where, if your motor is about to blow, if there's something wrong with your transmission, if we have that data that's in a cloud stored somewhere, I think it really helps us as customers, drivers, and owners of the vehicle too.
Yeah, I think that's one of the things that's kind of underappreciated is, for companies like Cruise and Argo AI that have fleets of vehicles that are going to be out on the road, for you to have a seamless user experience, right? So much goes into the back end. Like, for example, they have tire sensors to know when the tires are starting to wear out. They have these preventative maintenance, alerts, so all of that AI that goes into the back end that's going to pull information from the vehicle, and it's going to, run these algorithms to try to figure out when should I bring it in? It's run this long for this many days or on for this many hours. And then there's all of the sensors within the vehicle, trying to sense what could be going wrong. And then, so again, to maximize uptime of the fleet, there's this whole AI behind it that it really goes underappreciated in order for us to really have a good fleet experience and just get in, get out, and have as many rides as we want. Kind of.
Right. Absolutely.
I would just add maybe to the connected space. I think we can go back to the other question of one of the challenges is we can talk about if they're all connected, then everything will be great. But when's that gonna happen, right? So how long is it gonna take for enough that net this net effect where there's enough cars that are connected out there that are gonna make a difference in the user experience, right? So hopefully we don't have that many accidents that will set us back in terms of the industry and the adoption, because as fast as we can adopt and as fast as we can move towards a full connected automotive self-driving cars, then that's where the experience is going to be great.
Yeah, and I think a lot of that keeps coming back to building better infrastructures, right? If we have smart cities in place where you're able to support connectivity 24/7 and you can build your cities to support self-driving vehicles, I think that's what the future looks like. So to think about a self-driving vehicle on its own, I think we're kind of missing on the other piece of the puzzle here, and it's our drive towards building a better infrastructure all over the world to support this growth.
Yeah, and one I see the concerns with this is it's the smart infrastructure industry is very fragmented, right? You're talking municipalities, even sometimes just smart intersections within one city, right? So until we really have one kind of legislation that's going to help guide everything into one, you're going to have these makeshift kind of solutions everywhere that maybe are not compatible with some of the other vehicles. So that's one of the things that I think we're kind of missing today is this one central kind of organization that's going to dictate how smart cities work and how they connect with the vehicles.
And then
Sorry, you go.
I was just going to add very quickly, the problem that this industry is trying to solve is so hard because that's missing, right? If that was the baseline, then it would be quite easy.
I was just gonna, I guess I'll be the last one for that. just to bring awareness back to adoption in terms of, okay, yeah, there could be a smart city, but we have to look at ourselves from an individual perspective of, are we all going to adapt to the changes that that smart city could bring up?
All right, sounds good. All right, moving on to the next question here. The quality, size, and efficiency of how we use data does impact outcomes for AI in automotive industry. What is the best approach for this? Renata?
Yes, I think we can start. I'll start with size, the size of the data. As we just like talked, like there's a lot of like things that needs to be figured out. And imagine like crews right now, like they are figuring things out like in a very productive environment, but you have the whole world, right? Like adopting in the whole world, like that's a lot of data. That's a lot of different scenarios, a lot of different traffic signs, like all in different languages and weird symbols. So in a way, like the size of the data is so big that the problem can be maybe solved for a specific scenario, but then to actually increase adoption and move it to everywhere, you need enormous amount of data. And I think because you need enormous amount of data, you need to be very effective about it. If you want to get a good model, you need to ensure that the data that you're using is the right data and that you're not wasting time, right? So from the size of the data, we can move maybe towards the effectiveness of the data, of how are you going to be ensured that you're not wasting money, because it's money. If you think about data labeling, it's not like the Google caption that you can just like say what is a car, what is a, I don't know, bicycle. It's Cepton's like lidars are extremely complicated and very heavy. And imagine like someone annotating a world in a 3D environment. So we see everything in a point cloud, right? We have some 2D images in there, but it's huge amount of data and very complex, right? So if you go in and start annotating, I don't know, for a particular city, lots of kilometers, a lot of seconds, minutes, hours of recordings, and then you end up in the end, you have all your data, you build your model, and you realize there is something missing. And that's expensive, right? Like, think about that. So one of the key elements of that is really go back into understanding what are your truly needs and what are the different like requirements that you have set from the beginning. So to be effective at that process, you have to start with like a small scope, ensure that that scope is good, and then you can add on top of that. And then you can add on top of that, and I guess one of the scopes will be a city, right? A particular city. And after you solve that, you can continue on increasing and growing. If we're not effective, it's going to take so long to do it that it wouldn't matter, right? And then quality is my favorite one. Because at least like at Sama, we've been like leading and providing the best quality data for the last 10 years for our customers. And I think the key element in quality is not about being 100% perfect. It's not like, oh, your data is marvelous, like 100, there's no mistakes, but it's about rigor. So you can have noise. And if you think about like day-to-day examples, like we're reading a blog post or whatever, like there are typos in there. Or like in our day-to-day lives, we can see mistakes and we can ignore them. Deep learning models can also ignore mistakes, but there's different type of mistakes, right? So you have the type of noise that you can ignore, and there's a type of noise that like deep learning models cannot ignore. I think the key in having good data quality is to identifying and protect the data so that you don't get to those mistakes. One will be systematic errors. So for example, let's say you are annotating very complex stuff and half of the room, like you're all annotating point clouds right now. It's a 3D point cloud and there's one piece of the instructions that you didn't understand. Half of the room is doing one thing and the other half is doing the other thing. Imagine how the model will take that information. That's really hard to just isolate as noise. That will be an example of systematic errors. And then the other type of errors that you have to be mindful when building models, and especially for automotive, it's that if you're annotating a very large and complex data set, so there's a world and things are moving and there's so much happening in this world, sometimes there's like some small edge cases, but not necessarily edge cases, they're just small samples. So I don't know, a kid in a rollerblade like going around. If you end up having like bad quality on that particular like class, let's say, then you can look at the whole data and you're like, oh, I'm more than 95%, like I'm good, like the 5%, my model will be smart about it, it will ignore it. But then if you go deep into like a particular class, but that particular class is actually 50% wrong, then of course your model is not going to be good. So that's the other type of noise that you have to be careful about. And
I would just add that there's also kind of ethical considerations that go into, you know, when you're designing your model and data set, right? At Cruise, and I know like many other companies in the industry, we spend a lot of time thinking about like what the impacts, the broad scale impacts AI will have, especially with our technology. And one of them is just like being really mindful of there not being, you know, algorithmic biases or issues that basically result in disparate impact on different population and classes.
Right. Very good. Thank you for that. That was very informative. Moving on to the next question here. With developments in AI for automotive being under public scrutiny, there must be a focus on developing regulatory and around safety and privacy. You know, and I'll add a little bit of the privacy too. What is the regulatory environment currently like for AI in automotive, and how can we expect it to develop over the coming years? Lily, as our counsel.
So the regulatory environment, and I think this applies both in the United States and around the world, for transportation safety around kind of advanced driving technology and the privacy regulations, I would describe both as nascent and staggered. So, for example, in California, our privacy laws, California being, you know, where Cruise operates, our privacy laws only came into effect within the last year. And there are many states in the US today that don't have any laws around privacy. On the transportation safety side, those of you who are the OEMs are very familiar with the FMVSS, right? The federal regulations around vehicle manufacturing components. These are highly detailed and specified kind of like regulatory standards that are entirely built around the human driver vehicle, right? They don't take into consideration of like what would apply for a driverless vehicle. And if you think about it, you know, they're like, we wouldn't need a dashboard or steering wheel, but just because you wouldn't need it doesn't mean you get around the FMVSS, right? So then you need to go apply for the exemptions. You need to lobby for the law to change, and all of that takes a lot of time. And we're starting to see slow movement on that. There's a lot of state level and federal level interest. Similarly on the privacy side, right? Privacy laws don't really take into account of the implications of artificial intelligence. They are not really drafted, or when I speak about privacy laws, I'm referring to, you know, the CCPA, California's privacy law, and the GDPR. They don't really take into account the implications of AI and its capabilities, like, you know, for example, being able to de-anonymize data, something like that. And there's a lot of kind of thought and development that still needs to go into that. And my hope is that given the, you know, current kind of public attention as well as regulatory attention, we'll start to see new legislation, and like our lawmakers will be, you know, more vigilant about addressing these gaps.
Yeah, I think one of the more interesting things about that, especially to the privacy, right? I think these vehicles are creating terabytes of data every day, right? And the way I see it is a gold mine of data, right? Like the OEMs and whoever has that data can sell it to municipalities, insurance companies, and there's so much we can do with that data, right? But we do have the privacy issue. So I think in the United States, we really don't have as much in Europe, for example, for a policy around data privacy. You know, a little plug for LiDAR, right? It's anonymous data, so that's one of the cool things about it too. But that you can kind of use that data. It's very anonymous. But I just think that there is such a big opportunity that's untapped up to this point, right? Because once we get wider adoption of those vehicles with all of those sensors, think about like every single road in America or the world even, right, being mapped on a daily basis, right? Like how you can talk about, you know, what's going on in each road, how many people are, what kind of traffic do you have in certain areas, certain days, and correlate that to other events, right? So I think that there's just so much data that's being created, and how we're going to be able to either monetize on that, you know, as an industry, or will legislation kind of put a stop to that, or at least curb it a little bit? I'm interested in how that's going to go, because I think that could help subsidize the cost of the autonomous vehicles and make them a reality faster.
Yeah, I mean, data is such a valuable and important part of what we do within autonomous vehicles, right? So how we monitor that data, how we collect it, how we regulate it, I think is something that we're continuing to look towards. And with AV being such an emerging product, things are so they're changing so rapidly that it's hard for everybody to keep up, right? And then you start to think about, okay, each state has its own laws. So what you might be able to launch in a certain market or a certain state, you might not be able to do it in other states or other countries for that matter. So OEMs have to spend a lot of time thinking about what they can and can't do in certain markets, and then they have to kind of strategize around that and develop and build products around that too. And with the legal side of things, I think it's so important that a lot of the stuff is new. So we don't know what these laws would look like just because it's never been done. So there's a huge emphasis on understanding what we can and can't build from a legal perspective in different markets all over the world.
Yeah, and I would add on that in addition to laws like regulations, there's also this like variable of like what happens in our courts, right? So we're very conscious of what like early precedent setting cases could do to the entire AV industry. So for example, if a court did decide that strict liability applies for all, level 4 AV automakers, that could shut down the whole industry, because that would just be prohibitively costly, right? So like just flagging that as also being a risk factor.
Absolutely. All right. We're, I think, 5 minutes out here, so time for one more question. Oh boy, this is a LiDAR one, so I'm going to give it somewhere else first, and then I'll get to that. LiDAR is one of the new sensor modalities that are helping advance vehicle perception. Where do we each stand on the effectiveness of LiDAR? Omar, we'll start with you.
Yeah, sure. So, I mean, I think it's pretty well documented, right? How we use LiDAR, what role it plays in helping us build self-driving vehicles, right? And so, there's the cost aspect of what does it cost as compared to something like a radar, which is a substitute for LiDAR a lot of times. But one thing I will mention is that as important, as LiDAR or other technology is, and the pros and cons that kind of follow. I think what really is the foundation is sensor fusion, right? And what that means is you don't really focus on one specific aspect. So you can't just look at an autonomous vehicle and talk only about the LiDAR aspect. You have to look at all the data you're receiving from different sensors. So that would include your ultrasonics, that would include your camera systems, your vision systems, and you kind of paint a picture, putting everything together. You fuse all that data together, and then that's what kind of helps you build these self-driving cars. So you can dig a little bit deeper and look at what works and what doesn't work for LiDAR. And obviously OEMs have their preferences on what they'd like to use. Some prefer radars over LiDARs, but I think LiDARs is definitely done a lot to help us get to where we are, the development that we've seen and the results that we've seen. And LiDAR has been a huge part of that, but there's definitely other options that we look at. But being able to fuse all the data from a sensor fusion aspect, I think, is key.
Yeah, I think it's, like I said earlier, right? It's complementary, right? I definitely don't think LiDAR is going to substitute any of the other sensors. I think it shines, pun intended, on different environments, like detecting a pedestrian, where radar struggles with that. Detection at night of anything, when camera struggles with that, right? Computational power, LiDAR is much lower than that, right? I think so. And then when you look at the level 4s, at least up to this date, I don't know any of them that don't use it. So they all need it. And then publicly, most of the major OEMs already have announced that they're going to use LiDAR into the level 2 and level 3. Mercedes, BMW, VW, General Motors, there's a ton of them that already announced. So it's really getting a lot of, when people ask about like the need of LiDAR, you ask a LiDAR guy company, right? It's like, yeah, we're going to say we need it. But I think the better answer is, of course, when you look at the OEMs as options, the plans to roll out LiDAR, it really kind of just speaks to itself and how the industry, it's still in its nascency, right? So it's still very early, but it does have a pretty big impact on how much farther we can get to that last % of edge cases.
Maybe I can just add, I think it's a really good example of how important it is. If you're doing like the data annotation piece, when you're trying to annotate any type of sensor, like LiDAR just like gives like that whole like context, like the sensor fusion. I think if you fuse all the data into one and like you have a product that allows you to see like the LiDAR and it's connected to the 2D cameras and you can project from the 3D world to the 2D world, then even if like in the LiDAR, you can combine all those pieces of information so you can do the annotation, right? That is the same thing that happens with models. So they will use all these different pieces of information to inform like the models of what are the things that are going to happen, and then they can predict and they can be smart.
Yeah, I mean, I think it's a good problem to have, right? Like all these options you have, LiDAR versus radar versus other things, right? Like it's good that we have all these options available to us. So really it just comes down to strategy and results. Like how do you want to build your product? What's working for you? How well are you able to build the product around the hardware that you have?
And I think the last bit is that I love that the industry is really investing so much in LiDAR, right? Because it was so expensive, and now we can get it back to cost, and there's investment happening that allows for us to use LiDAR. Like for example, our platform supports sensor fusion across the board and all that, but it's not only for automotive. So it really opens the door for all these other like industries that wants to use this type of solutions that wouldn't be investing the money to the whole industry to be developed, right? But they can now benefit from it.